Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is ignition testing, and more specifically, modern ignition systems testing and analysis. Because if we think about modern ignition systems, coil on plug, and we got a couple different types of coils out there that we're going to talk through, some differences in there as well. But really, modern times, do we need to test ignition systems anymore? I really think we do. Let's think about it. Does OBD2 eliminate the need to test ignition systems? Because OBD2 is going to tell us exactly what's wrong with the car, right? Of course not. We all know that was kind of the promise way back in the day, but definitely not the case. And some of our customers, I might think that way too. We have the magic box in the back that tells us what's wrong with the car, but we know that's not true. So OBD2 hasn't eliminated that. How about newer ignition system designs? Does that mean we don't have to test ignition coils? Have you ever had a coil on plug ignition fail? Have you ever had an ignition coil, a coil on plug ignition coil fail? Absolutely. Happens all the time. So obviously we need to test there. And then how do you verify ignition system performance when you're diagnosing a drivability complaint? With a drivability complaint, I need to have fuel, air, spark, compression. So what's one of those? That spark thing. That's the ignition system. And actually, you can tell a bit about what the fuel's doing if you know what to look for when analyzing ignition. And you can kind of tell what compression might be doing if it's not the fuel and if it's not the spark. And maybe a little bit of the air, because we can tell the mixture. We can tell whether it's rich. We can tell whether it's lean, right? So we can tell a lot about just by looking at that ignition system. So here's an example. And I know I've walked through this before if you've seen any of my other videos, but it's always good to bear repeating. This is what we call a raster pattern on an ignition scope. We're going to talk more about that a little bit later. But what it is the raster pattern takes all of the cylinders ignition. You're going to, of course, hooked up to all the cylinders. It's on a 6-cylinder vehicle. And it's going to stack them on top of each other with the firing line all right on top of each other. And then we're able to see the spark lines. And we can see based on time, based on how that spark line looks, we can see whether or not that cylinder is performing the same as all the others. Now, this is coming off a vehicle with a drivability problem, had an intermittent drivability problem, a little misfire, hiccup, whatever, maybe not set in code. So they hooked it up and they took a look and they said, oh, they're pretty even. I mean, this one's a little bit shorter, this one's a little bit longer, it's got some stuff going on at the end, but by and large, those are pretty even time-wise. And there really isn't a lot of, they're all fairly flat. There really isn't a lot of weird stuff going on. So they said, all right, well, we can't really figure it out based on that. So let's go a little bit deeper and maybe do like a brake torque, right? So you mash the brake, you mash the gas, get it up to like 1500 RPM, whatever, with it in gear. And then it puts a good load on the engine and they got this pattern when it happened. Now you can see on this cylinder, it goes over and then it goes sharply up at the end. Now we'll talk about this a little bit later, but that indicates clean condition in that cylinder. All the other cylinders fared pretty much the same. This one might be a little bit too, because it's kind of doing some weird stuff at the end. But we can see this cylinder goes up, comes down, and we got a lot of wiggles going on right there as well. So this is a lean condition on that cylinder. It's a number 5 cylinder. And lo and behold, when they went and checked it, it wasn't actually an ignition problem. It was a fuel injector. It was a clogged fuel injector. And it wasn't allowing enough fuel into the cylinder under a load. So when that happens, you're burning the fuel, then all the fuel's gone. My voltage just goes off to the races. So lean condition causes higher voltage in my ignition system. So we'd be able to see that just by looking at the pattern. Conversely, if it was rich, it would go down. And we'll see an example of that a little bit later as well. So when we think about an ignition system, it's really a good idea to split it in half. We have a primary side and we have a secondary side. Now, I know this is a picture on an older system, like a cap and rotor and all that, but the principle is still the same. The principle still continues through. So we have a primary coil winding and we have a secondary coil winding. So the best place to split it's right smack dab in the middle. Anything connected to that primary coil winding, the battery, the ignition switch, if there's an ignition module, possibly pickup coil, cam sensor, crank sensor, anything controlling that ignition, that's considered part of the primary circuit. And then if we have the secondary circuit, that's anything from the secondary windings of the coil all the way out through the spark plug gap. So in this case, we have a coil wire that goes to the distributor, and then out the distributor, it goes through the rotor, out through the cap, and then down through the wire and into the plug. If I had a modern system with coil on plug, we would lose all of that, and then we would just come off the secondary coil. Maybe you have a little spring in there for contact, right? And then it's just sitting on top of the spark plug and goes out. Far less fewer parts, far less things to break, but we still can have problems. And we can have the same problem. We're not going to have a bad cap and rotor on a coil on plug vehicle, but we could have a bad coil. Could have bad windings in the coil. There's a lot fewer failure points, but we can still have failure, I guess. So a coil works, an ignition coil works on the principle of mutual induction. So that's a transfer of energy from one coil to another when they're placed near to each other. Coil connected to a voltage source is going to be the primary winding, and the second coil connected to another circuit is going to be the secondary winding. And then we're going to have a common conductor in the middle, common core. And it's usually cast iron when that happens, and usually we're using copper wire. So when electricity flows through a copper wire around a piece of iron or steel, what usually happens is we create an electromagnetic field. That's what happens, electromagnetic field. So it's going to build up an electromagnetic field in here, and then when we turn off the power to the first coil, that magnetic field collapses and it jumps over to this other coil over here and creates a voltage and current. Now on this side, the input side, the primary side, you see we got 10 turns of wire around this conductor. And on the secondary side, we have 1,000 turns of wire coming out the other side. So coming into this, we have 14 volts, 14 amps, and that gives us 196 watts. When we transfer over, since it's a factor of 100 to 1, 10 times 100 gives us 1,000, right? 196 watts stays the same, but the voltage is going to go up by a factor of 100, and the current flow goes down by a factor of 100. So I have 1,400 volts, and I have 1,400ths of an amp, right? So that's how the math works out. The voltage goes up, and the current flow goes down, just because of that difference. Now, it could be 10,000 turns. It could be 100,000 turns. It just depends on how the manufacturer designed the coil. And whatever the step-up factor is between either side, that's how we get our massive spike in voltage. Transformer works on the same principle. Solenoids, relays, they all work on a very similar principle. And you're actually going to get a very similar looking pattern as well when you look at it on a scope. But using this law of mutual induction is going to help us out when it comes to diagnosing the problem, because we can look at both the primary and the secondary side. We could look at them at the same time, or if we can't get to the secondary for some reason, maybe I don't have the right probe, maybe just I can't for one reason or another, then at least I can probably most likely, not always, but I can most likely look at the primary side and see what's going on over there, and it's going to be a mirror image of what's going on the secondary side. So we see this is the primary, comes in, we got our firing line right there, and we'll talk about all this in a minute. Firing line, spark line, coil oscillations after it's done firing. On the secondary side, you see I get a lot more detail. I got more oscillations on that side. I get a firing line with a little more detail, spark line with a lot more detail, and then this with a lot more detail. So basically that's your difference in voltage from a low voltage to a high voltage. You see this is spiking at, what, 15, 16 volts? This is spiking at like 70 volts. And that's still not in a kilovolt scale, right? Because it's not using that scale for the secondary ignition adapter. This is just basically the voltage that would come out of the secondary ignition adapter, which, by the way, leads me to a question that I get asked all the time, because other scopes, when you do secondary ignition, are like, oh, well, you need to use an attenuator in there to drop the voltage down so you don't fry the scope. On ours, our ignition adapters are designed to work with our scope, and we don't have that problem of needing an attenuator in there because it sends out a pretty low voltage as it is, and then it just translates it to an actual, here's what it is in thousands of volts. It's not actually sending thousands of volts to the scope, right? But I can still get a pattern either way. It's just a matter of I get a lot more detail on the second. So how do I test ignition? Well, I need a scope, a lab scope capable of ignition system testing. Pretty generalized there, because pretty much any lab scope out there can at least do some sort of ignition system testing, especially when it comes to our scopes. The 2-channel scopes, like on the Modus or on the Triton, those are going to be capable of single cylinder ignition. On the Zeus Plus, Varus, all those tools, they are capable of doing single cylinder ignition. Plus, they have a true ignition scope in it. So I can analyze my ignition signals a lot more deep than I would on a 2-channel scope. And that's just because it has the software in it to do that. So when I need to hook up, I need some adapters. So we have this inductive sync probe, and that can only be used with the 4-channel tools because they have that funky looking connector on there, and that is what powers it up. So this is, you put it around either the number 1 spark plug wire, if it has spark plug wires, or you can put it around the power supply, the number 1 coil, the power wire, and it should be enough to trigger it. And that is just to tell the tool, here's where number 1 cylinder is. And when number 1 cylinder fires, so that way the tool knows where number 1 cylinder is in the firing. That can be important. At a bare minimum, to hook up to one of our scopes with ignition adapters, it's going to need this cable right here. You see it's got the banana jacks that go into the scope side, and then we have the RCA jack on the other side. That's a standard connector, at least a while ago in the industry. It's definitely a standard connector in the audio industry. That's been around forever. It's got a male and a female, right? So the male is here, and then the female would be at the back of whatever probe you're hooking up to. This is a capacitive probe that would hook over a spark plug wire or a coil wire, or some folks have found recently, not that recently, maybe in the last decade or so, but you can unscrew the top of this, and it's got a little metal nub on the end. That little metal nub can then be placed on a coil pack on a coil on plug vehicle, and as long as it's got the right style of coil pack, which a lot of them are, but not everyone, and we'll talk about that. But you put it on the coil, and it'll read the ignition pattern off the coil. So that's wonderful that it's getting a secondary use or an extended use over what used to be. Now, these are available with just this, just the pair, or just all 3 all together in a pack. There's multiple different ways to get it. You may even have them laying in the bottom drawer of a toolbox somewhere, because these used to be packaged with like the 1st and 2nd gen Moduses. So if the shop ever had one or you ever had one, they may very well be sitting there because you might not have traded them in. Even like the early generation Varuses, the big boxy ones would come with these too. So you may very well have them. Otherwise, still readily available to this day. Also a stick pickup. So that's useful for if I have inline engine, or maybe like a 6-cylinder and I got 2 banks of coils, or an 8-cylinder, same thing. It'll run across about 4 cylinders worth of coil, and it'll pick them all up at once. Or we have these flag pickups, which are the most economical way to get into secondary ignition testing on coil on plugs. I think you can get a whole set of like 8 for under $100, or just a little over $100. It's not big money to get those, which is kind of crazy to think about. What can we get nowadays for cheap? But this is a way to do it. So you see they're available in singles, doubles, I don't have a picture, and triples. And there's a male and a female side, so I can chain them together however many I need. So you get 2 of these 3s and 2 of these singles, you can get an 8-cylinder, right? You can go up to 12 cylinders in the software on the tool. You can still do a V16. You just have to kind of massage it a little bit, I think. But yeah, definitely able to do that. And then there's also various part numbers of more vehicle-specific coil on plug adapters. There's one for like HEI. There used to be one for Ford. I think that one got discontinued though. Just clip over the side of those round coil that they had. There is one that's a COP11 that's kind of universal, and that one's useful, especially on the more modern coil designs we're going to look at in a little bit, where you can actually pick up a good pattern where others can't. We actually just redesigned it too, so that will be around for the foreseeable future as far as I've been told. The other ones are kind of specific to maybe older cars. I got one right here. It's a COP3. I think this is for like certain older Volkswagens and stuff, so that one might not necessarily be pertinent nowadays, but still readily available. And then you may have seen this lying around in the bottom of your toolbox too. I know there's plenty of people out there with them, and they just maybe don't know how to use them, or they don't get enough need to use them. But this is the Sun Ignition Adapter 2000. So this was actually originally designed to do waste spark vehicles. So it's got a positive side and a negative side. You just hook it up to all of them, and you just get you can measure the waste spark on a vehicle. Newer versions also came with RCA adapters that would go in there, and you could do 8 channels of RCA. So for those coil-on plug adapters that I showed earlier, you could just plug it into the RCA, and you could do all 8 cylinders on a V8 with that as well. Once I have it hooked up, what can I look at? Well, all of our scopes can do at least single cylinder ignition, like I said, so you don't need anything fancy for that. You just need a probe, and then you need to hook it up on a scope channel, and then you would be able to measure voltage. So in this case, we see the firing line. We can see the spark line. I went too far. I clicked firing line, spark line, etc. We're going to talk more about that in a minute. On the tools of the ignition scopes, the Veris and the Zeus Plus, you have the following 3 patterns. So we got the parade pattern here, which is used to check voltage between cylinders. You can see I got the firing order down here, and then this one's higher than all the rest, and this one's a little lower than all the rest. So those might be the suspect cylinders that I might need to look at. Basically, what you want to do is you want to put them all on the screen and see who's the odd man out. So that one's too high. That one's too low compared to the rest. So that might be where my trouble is, one or the other. Or they could be companion cylinders, and one could be kind of zapping off each other, right? So, as far as raster pattern, that we saw that a little bit earlier, and that is where it takes all the cylinders on top of each other, and then I measure based on time. Right. So what is my firing time? And I can take a look at the different spark lines and see what's going on with those. So I can see, is there an odd man out in the cylinder? Then we have superimposed. That is in the tool, but it's kind of a holdover from the earlier days when we used to do, the Sun machines and the other earlier scopes. It would be in there, but this doesn't label what cylinder is what, so we wouldn't really know what cylinder it is. We could see whether or not it's running evenly cylinder to cylinder, but if there was one that kind of jumped out, we wouldn't know. So that's what that one's for. So what kind of tests can I do to get these displays and get these patterns on the screen? Well, first one's a primary voltage test, so you don't need anything fancy with that. You just need a back probe. And you're going to back probe on the primary side of the coil where the power goes in. And you're going to take a look and see what it does. So in this example, this is on my car. Now the coils on Subarus, the coil-on plugs, are a little bit different because they have an igniter built in, so you don't quite get the same pattern you might expect on a 2-wire coil instead of 3-wire. So not necessarily the pattern you'd expect, but you can still get some sort of a pattern on it. So you can see the voltage comes in, 14.4, whatever. When dwell starts charging the coil, you can see it drops off. And then once it fires, you see a big spike there. It's only like a 4-volt spike, but still you'll see a spike, relatively big. And then that's where the spark line should be, but there's really not a lot of detail going on there. And then it just goes back to 14. So that's just because of just the drop off with the built-in igniter and everything. It's not. And then to compare that to secondary, like I said, they'll line up. So there's where dwell starts, and you can see where that starts there, and you can see how it drops off as dwell continues. And then when it fires, there's my firing line right there. There's a firing line right there, and there's my spark. There's my spark. So you can get a fairly similar pattern on like the 2-wire coils. I was on like I think it was a 2024 Nissan Sentra. They still use a 2-wire coil on that engine. And man, you get a really excellent primary side pattern on that just by back probing on the power side. It looks just like the secondary pattern. One of the better ones I've seen. So depends on the coil design. Your mileage may vary, but at least we have a few tests that we can do. Current probe test. We hook the current probe around the primary side, the power supply of the coil again, and then we can see the current flow through that. So you can see the in this example, it's going to curve up like this. We want to see a nice smooth ramp. We call it a current ramp. You want to see a nice smooth ramp come up. In this particular design, this is once again on a Subaru, but once it gets up to about 12 amps, we see it levels off. So that's what they call a current limited design. So the manufacturer decided they wanted to limit the current to, in this case, looks like about 12 amps. So once it gets to there, it just kind of levels off. And then when the coil fires, it goes down because all the current that was stored up in that coil goes away. Also, it could come up and come down like a triangle. If it's not current limited, it'll just keep going until the coil fires. Could see either or you could see a third option, which we're going to see in a little bit towards the end there. On the newer style coils, it does look nothing like that. So we can see dwell starts, current starts flowing in, firing line happens, the current drops off right away. Here's an example of a bad primary current. So this was on a BMW that has multi-strike ignition. So if you do have a vehicle with multi-strike, you will see multiple current bumps. It's where it fires the coil multiple times at idle and low RPM in order to burn off as much fuel as possible and use as much of the spark as that's available. But this first one's what I'm focused on. So you can see how it goes up sharply and then over. So that indicates an issue with the windings inside the coil. And you'll also note that it goes up, 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 up. So it's kind of making a little curve on the upward swing there. They replaced the coil and double checked and tested it because you always want to do that. Let's test a good one. And you can see it goes up and comes down like a spike. Like I said, that could be normal depending on the manufacturer. You can see how a spike goes up, comes down. Now, on subsequent firings of the coil, you will get this sharp uptick because it's fighting against everything that's still left over in it. So you are going to have that big bump in current there, but then it kind of levels off and goes. And you also note that it kind of goes in a downward trend. So it's using it up as it goes. Right, so we can see that. So that's an example of a good one on a multi-strike ignition. All right, we can also check the control signal, make sure the computer's actually controlling it, and make sure the signal that is getting the coil on the coils that have 3 wires. On 2 wires is power and ground. But in this case, we have a 3rd wire for coil control. And in the cases where that happens, it's almost always a 5-volt signal, just a square wave, on or off. So 0 volts is off, 5 volts. As soon as the coil sees 5 volts, that's its signal to start allowing current flow in and start charging up the primary side. When it drops off, that's when it says time to fire, right? So on, dwell, fire. We compare that with the secondary, we can see how it lines up. When it goes on, we start dwell. When it goes off, we fire. Okay, very, very cut and dry. And then secondary voltage. On coils that are able to do so, connect to a spark plug or coil wire if it has a wire, or directly on the coil on a coil unplug system. Like in this case, we got flags, and this is on, like I said, a Subaru. You kind of put it down the side of the coil, and you should be able to get a pattern. In this case, this is what we get. Now, it's not 100% like you would normally get off a spark plug wire because of how the probe works, and a little interference can happen. And it's a little touchy on this particular style of coil, like I said, but I was able to get a good pattern off. You can see dwell. That's where the primary side charges. That's where we fire. And we can see how we get a negative down here as well, which is unusual. Nothing was wrong with the coil, but that's just how that particular coil fires. And some of it might be due to the probe as well. And then we can see there's my spark line, and then it just kind of drops off. So if we were to analyze a textbook version of a firing line, you can see once again dwell. On the left there, you will see some coil oscillations there as it's starting to charge up the coil. Goes in, coil collapses, fires, get a big firing line, and then the spark line will come out kind of towards the bottom of the firing line. Then I'll get my spark line, and then I get these other coil oscillations at the end. Depending on how efficient the coil, the less efficient the coil, the more oscillations I have. That means it's got a lot of extra juice that it hasn't used up yet. So it's just ringing out and allowing that all to just kind of dissipate back into the line. If it's a really efficient coil, you get 1 or 2 or none. Just depends on how efficient the coil is. And that's where it's kind of recovering. And then we start dwell again, and we start back over here. Starts back over again. So the voltage of the firing line is going to be dependent on what's going on inside the cylinder. High firing line voltages can be caused by wide spark plug gaps just because I have a larger distance to cover. Lean air fuel mixtures, because the fewer hydrocarbons I have to burn, the voltage will go up, the leaner it is. High cylinder pressures, because it's harder to get the molecules apart because they're being pressed together so much. And then retarded ignition timing because of where it is in the piston stroke, because that'll change the dynamics in the cylinder. Right? So check the firing line either as a single cylinder or with other cylinders for comparison. I would definitely recommend other cylinders for comparison, because we always gravitate to the one we think is bad, and then we wonder why the pattern looks bad. We don't want to do that. So we can check through individual cylinders, multiple cylinders if possible. A couple of tests we can do is a cranking test, a cruise test where we hold it at about 2,500 RPM, and then a wide open throttle snap. You can do all this parked, in park. Here's a cranking test example, wide open throttle in this case, because you don't want the you don't want any fuel in the cylinder. In this case, this car had clear flood when you hold down wide open throttle. So in this case, wide open throttle, and we can see fairly even firing lines, about 10,000 volts each. You can see some spark lines. That looks pretty good. It's off of my car. Being that it was off of my car, I was actually in the middle of doing a tune-up when I did this. It had about 120, 130,000 miles, something like that, on the original plugs. The Iridium plugs, they probably weren't even really due, but this is where I'd replaced 3 out of the 4 plugs. Which plug had I not replaced? Well, of course, it's this one, because the spark plug gap is considerably wider because it's got 120,000 miles on it. So you can see it goes off the screen. It's 18, 20 volts. I don't know how, 20,000 volts. I don't see how far it went up. But you can see a big difference in that pattern because that was the one worn out spark plug. The other 3 were new. Interesting stuff. Here's an example of a bad coil. This is on a vehicle that had just a single coil, cap and rotor type design. It just wasn't putting out enough to even make a spark. It couldn't even cross the gap in this case. Here's back to my Subaru's cruise test, 2,500 RPM. So just in park and hold it at about 2,500. The top should go down due to the timing advancing. So we should see that, and that's correct. And then when you let off the gas, they should go back up to about where they were at idle. We should see a bit of turbulence in the spark lines too. We'll talk more about what that means in a minute. And a wide open throttle snap, just hammered down on it in park, wide open throttle, and see what happens. Got up to 5,000, 6,000 RPM. The firing line should increase off idle. So once it goes up, it should increase, and then it'll slowly decrease after the throttle closes. So once I let off the pedal, it should come back down. Going to see a lot of turbulence in my spark line just because there's a lot of swirl and a lot of stuff going on inside the cylinder when you're doing a wide open throttle snap. Spark line diagnostics, going to be very much similar to firing line because it's just voltage inside a combustion chamber, so the same rules apply. Length and shape of the spark line will be affected by what's going on. Spark line should jump out horizontally from the firing line, and it should show some turbulence. Turbulence mean that I have a homogeneous mixture, a fairly homogeneous mixture in there. It's going to be a little richer in one spot, a little leaner in one spot, so I get these little variances in the spark line. It can be anywhere from 0.85 to 2.5 milliseconds in length as a rule of thumb. Lean mixtures are going to increase, rich mixtures decrease, like we said. So if I look at this spark line, it's on a different car. This is on one with a spark plug wire. And we can see fairly flat. This is a normally operating vehicle, runs perfectly fine. I see a little bit of turbulence in there, nothing major. As overall, it's pretty flat and fairly efficient coil, only a couple little oscillations down there at the end. Versus, same car, took some pinch-off pliers on the fuel supply and started making it start for fuel, so make it a little bit lean. So you can see right there, normal, because I had a normal amount of fuel, but when all that fuel went away, started going north. All right, so that is an indication of a lean condition in that cylinder. And then it actually kind of started to stall a little bit towards the end. So you can see it kind of hiccup a little bit there. And that's when I just released it and allowed more fuel back in. So you can actually see all that going on in that little short amount of time of a pattern. But the key indicator is the up at the end, right? Comes out flat, goes up. Conversely, we have goes down. So this was on the vehicle, was giving it a tune-up, had not given it a tune-up yet. So it was a little richer in there, was burning more fuel, was being less efficient. So we see it kind of goes down before leveling off. Now this next picture, it looks like it's going down, but once again, that's probe placement and kind of just how that coil works. So what I wanted to look for is it's straight. It is straight. Doesn't have this curvature like that. So it kind of was headed down curve and then it flattened out. Whoops. This one is just kind of straight across. So if it was maybe move it a couple millimeters in one direction or the other, it might have gotten a little straighter. Can be a little challenging sometimes to get 100% pattern, but it's a good rule of thumb, right? Here's an example of what you might find on a multi-strike. I think this is like a Ford Edge, Ford Escape, something like that. Has multi-strike at idle, so it'll fire that coil multiple times in a row just to burn off all the fuel and to use up all the coil energy as well. And then we get to our newest-ish coil designs in the world. So a Hemi has this weird looking coil. I don't know if you've ever seen one of these, but these are pretty much impossible to test secondary wise just because of the design. They have some electronics in here, a little diode in there. Plus you got 2 spark plugs. So that would be a wild looking pattern if you could. So if we look inside the cylinder head, you see it's got 2 spark plug holes just to give it more efficient combustion. Even from the OEM, on the 3.6 doesn't have that, but on all the others they are. So on the 3.6, it gives you a primary and secondary resistance. On the Hemis, they all have the same resistance on the primary side because they all use the same coil. On the secondary side, there is a spec, but you'd probably have to take it apart. It's not directly measurable due to a diode in the circuit. So I can't just go on the power side and the other side and see what the resistance is. Not going to work. And then we get to this Hyundai Palisade, which is along a similar idea, right? So we got a little diode in there. It's got a little igniter circuit. So the ECM sends the ignition signal. We got ground, we got power from the battery, right? And you got primary side, secondary side, and you got your spark plug down. So with these, they act a little bit differently than other coils that we might be used to, like a 2-wire coil. Since it has the ignition, the igniter components inside, it's got a little IC in there or something like that. Here's what the current flow looks like. So that was a current ramp test on that same vehicle. And you can see just a lot of squiggly lines. It's kind of wild how that works. And then secondary ignition, I was actually able to get a halfway decent pattern out of it. And this was using that COP11 I talked about. It's kind of a more universal. It's adjustable. And it's designed to work on the newer style coils and give you at least some semblance of a pattern. And I think that looks pretty darn good. Got a little weird over here. Got a lot of oscillations going on that firing event. And it goes negative over here, which is also a little unusual compared to your textbook. But you can see the oscillations there. You can see the oscillations there. You can see your spark line. This car only had like 8,000 miles on it, so I should hope it didn't have a drivability problem. It looks like a pretty textbook, fairly textbook in there. So that was kind of interesting. All right, let's walk through real quick live. I know I'm running a little long tonight. But we'll walk live on the tool and talk about some ignition-specific stuff that we can look at. So, for example, if you have one of our tools with a scope, you will have guided component tests in there. So let's go in there and let's just look at, let's look at our BMW test board. How's that? So we go in engine and let's see, ignition tests. We got primary tests and secondary tests. When we go to primary tests, we have a key on engine cranking, resistance, signature test, and a current ramp test that we can do. It's going to show us what it's supposed to look like, how to hook up our low amp probes. It's going to look kind of like that. And there's an example of multi-strike, just like it should. Signature test is going to be looking like that. And there is a multi-strike there. But we can see there's your textbook ignition pattern. That's primary. And then if we do secondary, we can check burn time with that COP11 I was talking about. So you can come down here and it's going to give you some bit of a pattern. Burn time is shorter in other cylinders. Check for possible high resistance. Burn time is longer. Check for possible short to ground, cracked spark plug, etc. So it gives you some indicators of what to look for there as well. Now, as far as scope functions, we can go into the straight scope. And we see we got the lab scope, or we can go into the ignition scope. So if I go into the ignition scope, and like I said, this is only on the 4-channel tools. The 2-channel tools can still do single cylinder ignition. So if you go in there, it's going to look something like this. I have a little simulator running that's giving me a sample pattern here. So you'll be able to see that. And just take a kind of 10 to 20 milliseconds is a good rule of thumb for time if you need to set it up. And then, this is in thousands of volts because I got my ignition probe on here. So it's doing secondary ignition with ignition probe. On the 4-channel tools, we have these other 4 patterns that I showed you earlier. So we got parade, which is going to show all of them in line. Now, it's probably not going to, it doesn't default to this, so you do need to do a little bit of setup probably. So if you go into setup up at the top, go to setup again, and click ignition, it's going to ask you what kind of ignition system is it, how many cylinders, what's the firing order, and what is number 1. So do I have it plugged? Do I have it going off the coil or the plug? So coil is for RPM, plug is for triggering your cylinder. And it will calculate RPM because it knows how many cylinders are there and it knows how often it's firing. So it knows it'll be able to calculate RPM. Once I've done that, it puts my firing order down the bottom. 1843657 small block Chevy, some Dodges. And then it can see relative to each other, how do they look? One higher, one lower. These are all going to be pretty much the same because it's a signal generator just sending some stuff out, but you can see that. So that's parade. We also have cylinder. Now, cylinder is going to allow you to look at one cylinder at a time, but a little bit different. So in this case, it's just going to put one cylinder on. And if I come down here, I can tell it what cylinder I want to look at. Since I have the firing order and I have it hooked up to every cylinder at the same time, it can show me as I cycle through the different cylinders. Now, of course, it's going to look the same on this because it's just a simulator. Now, another key point I wanted you to remember as well, if you're having difficulty getting a pattern in the ignition scope, check this triangle. This triangle is your trigger when it comes to this scope, and that voltage has to pass through this. So I bring it down to like 6,000, passing right through it. Bring it down to like 2,000, yep. Bring it up to 14,000, it's not that high. So mess around with this a little bit, bring it down, 4, 5, 6,000, and see if you get a pattern. That's usually a common issue that some people will have. Then if we look at raster, that's the on top of each other one, where I can see if different cylinders are doing what. And then we have superimposed as well. It's going to be on top of each other. This should be fairly even because, like I said, it's simulated. Now there's one more little hidden gem in here, and it is hidden. But this could be useful depending on what you're doing with your ignition testing. So we're going to setup, view, display. First off, we can go to RPM. So it's going to show us our RPM calculation on top. Could be good to know. We got to show grid, which turns on the grid lines, which can be useful for any pattern. And then we also have show digital KV. So what this does is it takes the picture, since I have everything hooked up already to every cylinder, and it gives me a numerical value based on what is my firing line, how high is it, maximum, minimum, and actual, what's going on per cylinder. Spark KV, where does that spark line come out? Should be about 2,000 to 3,000 volts, maybe a little less. And then burn time. What's my burn time per cylinder? So I can see if there's a problem child, I would be able to see it right there just by looking at the number. So we have multiple different ways of doing this. I suppose if you're an engine builder or something like that, tuner, wanted to see how that engine's running and make sure all the cylinders are running correctly, that might be a good thing to have. Could be a good printout to send out. Could be good to have a discussion with a customer about. So to turn that back off, we got to go back into view, display, uncheck. Because otherwise it's going to default to that next time you go in and you're going to wonder how to get it. All right, so that is our quick and dirty, down and dirty ignition course. Hopefully you picked up a few little tips and tricks. Maybe you could even use it tomorrow in the bed. So that is, like I said, ignition. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free, once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.